Have you ever really thought about what's going on inside your phone when you're on a train just streaming music without a care in the world? It seriously feels like magic, right? But it's not. It's actually this incredibly complex, high-speed dance of digital handshakes. So let's break down how your phone pulls off this amazing feat.
You know the feeling. You're cruising down the highway, your favorite playlist is on, and there's not a single buffer. Or maybe you're on a bus in a city you've never been to, and that little blue dot on your map is just perfectly glued to your location. It just works. But behind that totally seamless experience is this constant, relentless negotiation between your phone and the network. So how in the world do they actually pull it off? I mean, the scale of this whole challenge is just mind-boggling when you stop to think about it. A cellular network has to juggle millions of devices. Millions, all moving at different speeds in totally different directions without the entire system just collapsing. It's like being an air traffic controller, but instead of a few hundred planes, you're responsible for every single phone in an entire city. It's wild.
Now, you might think the network is tracking your phone's exact GPS position every single second, but that would be, well, a total nightmare for the network and your battery. So instead, it uses a much smarter system. It's this really clever combination of identity and location that basically acts like a digital passport. It tells the network just enough to keep you connected, but not so much that it gets completely bogged down in useless details.
Okay, so to manage you efficiently, and more importantly, securely, the network gives your phone two key pieces of information. The best way to think about them is as the where and the who of your mobile connection. So this digital passport of yours has two main parts. First up, you've got the where. That's the routing area identity, or RAI. The network is constantly broadcasting this out, and you can just think of it like a big digital zip code for a whole neighborhood. It tells the network your general location. Then you've got the who, the PTMSI. This is a temporary private ID that's assigned to your phone only while you're in that specific neighborhood. It's how the network knows it's you without, shouting your real identity from the rooftops for everyone to hear. And this is where the real genius of the system comes in. The where, that RAI, makes the whole network incredibly efficient. Because it only really cares about your general neighborhood, not which specific lamppost you're standing next to. It doesn't need all these constant, tiny little updates. And the who, the PTSII, that's what protects your privacy. By using a temporary ID, your phone isn't just broadcasting your permanent identity to the world 24/7. It's a really brilliant balance between performance and security. So what happens when you actually start moving? Let's kick things off with the most common scenario, just small movements within the same general area. Okay, imagine you're just walking around downtown or maybe driving through a few suburbs. Most of the time, you're moving inside one large zone that's all managed by the same regional network controller. The technical name for it is an SGSN. So even if you pass dozens of different cell towers, you're still reporting back to the same manager. And that makes the whole process of updating your location super, super simple. The whole process is incredibly lean and fast. As soon as your phone notices it's in a new zip code, a new RAI, it just shoots a quick message to that network manager saying, "Hey, I'm over here now." The manager checks your temporary ID to make sure it's you, updates its file, and sends back a quick confirmation. That's it. It's this tiny little digital handshake that happens constantly in the background without you ever noticing. But what about a bigger move? What happens when you drive from one city to the next? Or you take a train trip that's long enough to cross into a completely different network management zone? Things get a little more complex. Right, so here's the key difference. A small move is just a quick status update to the manager you already have. A big move, though, is a full-on handoff to a new manager. When your phone crosses into a new SGSN's territory, the old one has to securely transfer your entire session file, what's called your user context, over to the new one. It's kind of like your file being seamlessly passed from one office branch to another as you travel, making sure your connection never ever drops.
Okay, so that covers a phone that's actively moving and using data. But what about a phone that's just sitting idle in your pocket? I mean, the network still needs to be able to find it if someone calls you, right? Think about it. Constantly tracking the exact cell tower for an idle phone would be a massive drain on your battery and on the network's resources. So to save power, when your phone goes into standby mode, the network, well, it kind of relaxes. It stops tracking your precise spot and only remembers your last known general zip code, that routing area we talked about earlier. So this creates a brand new puzzle. If the network only knows your general neighborhood but not your exact street address, how does it deliver an incoming call or a text message directly to you and not someone else?
The answer is a really simple, almost elegant process with a name you might even recognize from back in the day: paging.
Yeah, think of it like the network getting on a giant digital loudspeaker. It broadcasts a message to every single cell tower in your last known zip code, basically shouting, "Paging the device with this temporary ID, where are you at?" Your phone, which has been quietly listening this whole time, hears its ID being called, wakes up for just a split second, and replies with its precise location. And only then does the network actually connect the call. It's a ridiculously efficient way to find you without constantly killing your battery. So there you have it. That's the invisible dance that keeps us all connected. A system of digital zip codes, temporary IDs, and broadcast pages. It's this ingenious system that was designed decades ago to perfectly balance the network's need for efficiency with our need for privacy. But as our world fills up with billions more connected devices, from our cars to our coffee makers, it really begs the question, is this balance still the right one for the future? How much privacy are we willing to trade for even faster, even more seamless connectivity? Something to think about. Thanks for tuning in.